In this tutorial, we are going to see how to set up a ratings model and how to enter the judgments. We are going to start by opening one of the sample models that you can find under Help Sample Models. We are going to use the card selection AHP model as a starting point. When we have a ratings model, we do not need to have an alternatives cluster. So since this AHP model has already an alternatives cluster, we are going to delete it. In today's model, we want to also have a cluster for subcriteria, which we are going to create. Let's call it comfort subcriteria. And we are going to add in there two subcriteria, which will be the driving performance and the ride. Now we need to connect the comfort criterion to its subcriteria. We will use the make show connections, select comfort, and then driving performance, ride, and don't forget to click enter to register the last check mark. Let's check that our connections are correct. Yes, comfort connected to driving performance and ride, and from goal node we have connections to all the other criteria. Now, if this was a new model, we would need to enter the judgments for all the criteria, but since we started from an existing model, we are going to add only the judgments related to the new subcriteria, driving performance versus ride. We think that driving performance is a little bit more important than ride, so we are setting a 2. You will never have an inconsistency when you have just one pairwise comparison, so we can mark it as completed and go back to our model. This is a good point to save your model, since the next step will be to create the ratings model. To do so, we need to click on the ratings tab to start the process. And then we are going to add the bottom level criteria. That means that I'm adding by double clicking prestige, price, miles per gallon, but I'm not adding comfort since it's not the bottom level, but driving performance and ride are the bottom level criteria for that specific branch of our hierarchical tree. Then we are going to add the same alternatives that we had in our previous model. However, normally a ratings model is used when we have a lot of alternatives and not just 3 alternatives. That's exactly the point of having a ratings model. We use it when we have too many alternatives, and making the pairwise comparison will take too much time. Don't forget that when we compare using the ratings model alternatives, we need to have an ideal in our mind, and we need to be quite experts in the field, otherwise the results won't be very reliable. So now we added the alternatives, and the next step is to define a rating scale for each criterion. For each criterion, we need to create a scale. Let's start by selecting the prestige criterion. When we are talking about intensity scales, there are different things that we can do. We can use an existing scale, we can create a new one, or edit and modify an existing one. Let's start from prestige. For prestige, we can use a new one. So I'm going to click load from file. I'm going to use one of the existing scales. Scales are saved in files with an extension of RCP. Let's use an excellent to poor scale. I see the values. They look pretty good for our purposes, so I don't need to make any changes, and I can go to the next criterion. It's price. For price, I would like to create a scale that will reflect the prices of the 3 items. So I'm going to add ranges for the prices, 30 to 35, 22 to 29. Now that I have completed adding my 3 scale items, I'm going to pairwise compare in order to create the actual values for these items. So I'm going to click the compare button, go to the questionnaire mode, and evaluate the price ranges. I think that the 30 to 35 is not as good as 22 to 29. So 5, strongly more important, actually strongly more preferred in our case, is the 2029 versus the 30 to 35. And when we compare 30 to 35 to 16 to 21, it's even more preferred the 16 to 21. Similarly, for the 22 to 16, 16 is quite better. We're gonna click on our window, show new priorities to see the priorities that we just gave to the three components. And the inconsistency is good. And it seems that we prefer the lowest price, which is what we wanted to do. So we can go to File, Save and Close, so the values can register. And now we see updated the values for our scale items. For miles per gallon, I'm also going to create a custom scale, which will have exactly the values that we know from the profiles of the cars. So it will be 29 to 32, the first item, 22 to 30. Actually, let's make it more precise, 22 to 29. And the last item will be 20 to 22. Now I'm gonna again compare to get the values. And obviously the 29 to 32 is a better choice, but there is no huge difference to the 22 to 29. So I'm using number 3 for the comparison and number 4 for 29 to 38 versus 20 to 22. Last 20 to 29 versus 20 to 22, they are quite close. Computations show new priorities to see the results. More mile per gallons, higher priority. That sounds good. So I'm gonna save and close. And now for driving performance, let's use our high, medium, low scale that already exists. While for the ride, I'm going to create a new scale, luxurious ride, very good, and average. And I'm going to pairwise compare, so we give values to the items. We can actually use even direct entries. For example, I could say that luxurious is the one that I think that should have the highest value, then very good. And for average, I will give the 0.1. Let's see our priorities. We see that the difference between very good and average is not huge, so we are gonna improve a little bit the third comparison because very good is better than average. Let's update the values. Yes, now it seems to be a little bit closer to what we initially wanted, so I can go to File, Save and Close, and have my new values. Now that I have one scale per criterion, and we are allowed to reuse scales as much as we want, or save scales that we like, for example, if I like the scale that I just created for ride, I can save it to a file by naming it. By default, it will go under the scale. Let's call it ride scale. And that means that if I wanted, I could reuse it either in the same model or in any other model. And we finished the third step, that was to define a rating scale for each criterion. Our next step will be to evaluate the alternatives in the ratings table. If we have a lot of alternatives and the table doesn't show up, a good idea would be to close the model and super decisions and reopen it, of course, after having saved. That way, it will refresh the number of allowed rows and you will be able to see the full table. Whenever we use a scale, we have 3 ways of seeing the scale items for each section. Category names, that is just the name of the scale items that we just created. Priorities, that is the attached number, or both if we want to have an overview of the numbers that we are using. The show height allow us to define whether we are seeing the priorities and the totals column or not. The calculations refer to the different kinds of calculations that we can do. Synthesize will give us the temporary results for the 3 alternatives. Of course, now we haven't entered yet any ratings. Synthesize whole model is used when we have a multi-level network and we want to see the ratings synthesis result. And column priorities give us the priorities of the columns that we are using, so the priorities of the criteria that we are using. It's pretty handy if we want to copy the values in a report or an Excel spreadsheet. Finally, in the Manage Ratings section, we can copy all this table to clipboard so we can paste it in a Word or Excel spreadsheet. We can clear ratings judgment that will clean up this table without affecting the actual model. And we can revert to relative model. Revert to relative model will totally delete everything that is related to ratings. We use revert to relative model in two situations. If we have come in the ratings tab by mistake and we want to get back to the HP or AMP model, or if we need to clean up and restart all of the ratings process. The next step is to enter judgments in our ratings table. For each of the lines, we usually go through the line. Accurate TL had a pretty good miles per gallon consumption, driving performance high, luxurious, let's say. Don't forget that when we are rating alternatives, we are not comparing them to the other alternatives, but to the ideal that we have in our mind. So when I say that accurate DL is excellent, it's not very good because, for example, a BMW or an Audi could be thought that they are more prestigious. So we would say that prestige is above average. We need to be very, very careful because not having pairwise comparisons, we have to keep in mind that we are comparing every entry that we set in with the ideal car that we would love to, and we are not comparing the alternatives that we have to each. Let's set in the values for the rest. As you notice, it's much faster to enter the ratings as opposed to setting up the judgments in pairwise. However, it's much more difficult to be objective and to avoid comparing the alternatives that you have in hand and keeping always in mind the objective true of an ideal car instead of using the pairwise comparison. We can synthesize to see our final result. Acura, Honda Civic, and Toyota Camry. So we changed a little bit our second choice based on our ratings model. So in this tutorial, we managed to see how to convert an HP model to a ratings model using a sub-criteria cluster, how to add the criteria for the ratings model and the alternatives. Very important, how to define rating scales or use existing scales for each of the criteria. And finally, how to enter our judgments in the rating